All right. So here we have a situation where the U.S. Army conducted a test of 1,000 new recruits. And we're told that 650 of those recruits are men, 350 were women. And what they found was that 40 of the men and 3 of the women were red-green colorblind. Okay? So the question is asking, given that a recruit is selected at random from this group, given that they're red-green colorblind, what is the probability that the recruit is a male? Okay, well, again, I'm going to use a Venn diagram to represent this situation. I've got two events, right? I'm going to separate this into two events. Either they're red-green colorblind or not, or they're male or not, right? Because I'm kind of interested in the male because that's what the probability is asking for. So I'm going to choose male and not female. Um, okay, so I'm going to call the event of being colorblind. I'm going to call that C for colorblind. And the event of being male, we'll call it M for male, right? And they overlap, right? Some of those males are colorblind, so they overlap. The whole sample space is 1,000 recruits. 1,000 people were tested. Okay, 1,000 new recruits. And let's see, what else are we given? We're given that 650 of these were men. Okay, so I know that the set of men, is 650. Which means that, yeah, with 350 are women. And then 40 of the men were colorblind. Okay, so 40 of the men were colorblind. So 40 of them are in that intersection. Now, we've got some other information too. We know there are 350 women, but some of those women are colorblind and some are not, right? So some are going to go inside this colorblind circle and some are not. So we can't really split that up yet. We know that 3 of the women were red-green colorblind. All right, so that means that there are 3 additional people in the colorblind circle that are not male, right? Because we're going to make the assumption that the recruit is, if they're not male, or if they're not, if they're either male or not male. So we're going to just assume that. Okay, so that tells us that we had a total of 43 people that were colorblind. Let's see, what else can we figure out? We know that there were 610 males who were not colorblind. And now we can also figure out how many people were outside, how many women were not colorblind, right? So basically, well, I guess we had 350 women, and 3 of them are colorblind, so then 347 have to be not colorblind. Okay, now that should all add up to 1,000 if I did everything right. If I add 3 plus 40 plus 610, that's 653, and that adds up with 347 to be 1,000. Okay, so everything works out. All right, so what are we asked? We want to know, given that the recruit, select him at random, is colorblind. Okay, so we're given that, given C is true, colorblind. Then we want to know what's the probability that they're a male. Okay, so we're asked to find the probability of being male given that they're colorblind. All right. Well, so now we're restricting ourselves just down to that pool of colorblind people, right? So let me draw a circle around that, right? Because we're given that they're colorblind, right? So we can restrict our sample space just down to those 43 people. So what I want to know is the number of people who were male and colorblind, right? Out of the total number of people that were colorblind. All right. So we know that the number of people who are male and colorblind is 40, and we know that the total number of people who are colorblind are 43. So if I do that calculation and get it as a decimal, I get 0.93. So about a 93% chance that if you happen to select a colorblind person, that person is most likely male. All right. So I will meet you in the next video.